Hello. Okay, welcome to the third talk in the developer track today. It's my pleasure to welcome Chris, who's going to tell us all about time series stream processing with Spark and Cassandra. Please join me in welcoming our speaker.
Thank you very much. Is this working? Can everyone hear me at the back? Good? Brilliant. So I'm going to talk about something quite different than most of the talks here. It's about building operational systems. So I'm not going to be talking about building analytical or data warehouse or data swamp or data whatever. My experience is very much with building large-scale operational systems that end up with a huge amount of data inside Cassandra, and then you want to do something interesting with it without extracting it. So hopefully that's what you're expecting. My background is I'm an independent consultant, contractor, software engineer. I mainly work with companies who are using Cassandra, and then I'm normally encouraging them to use Spark for some things as well. Normally when I talk to people, though, I'm talking to a very different audience. So I normally assume everyone understands everything there is to know about Cassandra. Who here has actually ever used it? Anyone in the audience? More than I expected, so that's good. I'm normally then trying to persuade people who have taken the Cassandra pill to then run Spark on top of it as well. All right? And normally for a couple of different reasons. So either trying to do some batch analytics on top of the data already in Cassandra, or changing your ingestion path. So very often, people, when they build Cassandra applications, what they're doing is they're pre-building every way they want to view their data. Because the size of the data inside Cassandra is too great for you to be able to do, say, any aggregates or group bys, et cetera, because you're talking about terabytes or petabytes, which, when it's an operational system, is a lot of data. But as I said, I'm assuming everyone in the audience is very Spark literate, so I won't be going through any Spark introductions. But I will, however, explain how Cassandra distributes data and just the useful bits for running Spark on top of it. So as I said, we'll understand how Cassandra distributes data. We'll understand how the way Cassandra can split data between data centers, and we can do workload isolation between our Spark batch jobs and our operational system. We'll be talking about a specific example, which is time series data modeling. Now, virtually every application I've built with Cassandra has a schema similar to the one I'm going to show today. So if you don't care about weather data, you can just squint and assume it's trade data. Or at the moment, I'm building one for keeping track of most of the things that people are trying to do with an internet television provider. And another one is keeping track of everything any customer has ever done with, say, order processing and keeping track of them, being able to do analytics on top of the order, all of the order history for all of your customers. I'll explain exactly which parts we can achieve just with pure Cassandra. This has changed quite a lot in Cassandra 2.2 and Cassandra 3, where we can do a lot of very simple group by and aggregates and reporting inside a single partition inside Cassandra directly with Cassandra, though that's not production ready yet, so don't use it yet in production. And then we'll turn what scenarios are we're actually going to introduce Spark. And obviously the main two ones are batch processing and then, modifying the ingestion process to start doing stream processing for the data coming into Cassandra. So I see them as very different worlds. So when I see people talk to people who are pure Spark and Hadoop people, we're obviously doing things like batch processing, we're doing ad hoc querying of large data sets, probably some machine learning, and then stream processing. None of that is anything, the people I normally talk to on a day-to-day basis, they don't actually do any of that. They're using Cassandra to build an operational database. So we're talking about the backing of websites, trade processing, online television, things like that. So what am I doing here? Am I in the wrong place? Well, no, because people are using Cassandra as opposed to, say, Postgres or Oracle, et cetera, when the data sets get extremely large. And they're spread across many, many servers, which is obviously a perfect sweet spot for Spark, because that needs data spread across lots of servers to do interesting things. So let's just understand how Cassandra partitions data, and then understand how Spark runs on top. So I'm assuming most people have used a relational database or a traditional database, and they've set up a master-slave architecture, and all the writes go through the same place. If you want to understand how Cassandra works, you just forget it doesn't work anything like that. Then when you come to actually scaling out the quantity of data inside your operational system, then typically you're getting into the joy of sharding. So either at the application level, you're actually interacting with multiple different full database instances, or certain databases obviously support it natively and will shard the data for you. Again, it's not going to look anything like that. Cassandra spreads data across many different servers so that you can actually go to any database server, and query any part of the data. It's a bit like Mayhem. Just go to any server you want. Obviously, it's not Mayhem. What Cassandra allows you to do is, without having a single master for any particular piece of data, is replicate data n number of times and to be able to deterministically find it. So the algorithm for working out where your data is across potentially a cluster of tens, hundreds, but even thousands is deterministic. So that means you can go to any node in the cluster to get the data. It also means that all of the Cassandra drivers now work out the same algorithm and just go to the right place anyway. That obviously works with consistent hashing, like most of these things do. So in Cassandra, we partition the data off a particular field. So in this example, pretend that we're partitioning the data based on Jim. Now, what that means, the name. So what that means is all of the data which shares the same partition key lives on the same node. And that has some large ramifications about what you can actually do with just pure Cassandra. You essentially have to stay within an individual partition. So if you've got 1,000 nodes, you can only do things which live on a single node. So what do you think we use Spark for? For the things when we want to do something with all of the data across an entire Cassandra cluster. The way this works is, Cassandra hashes Jim, or your partition key. Now that goes to a huge range, a bigger number than I could fit on this slide. But just to explain it briefly, we'll assume it goes between 0 and 999. Each node in the Cassandra cluster then owns a token range, a range of that hash function. So if we know if our partition key hashes to 50, we can work out which node owns it. It doesn't end there, though. So if this were the example, and we had 4 pieces of data, and we were doing some really big data analytics with 4 pieces of data, we would take Johnny, we would put it in our database, then node A would go away, and we would lose poor Johnny. So that's not the end of it. The second thing which happens in Cassandra is replication. Now, when people are building operational systems with Cassandra, they use the replication to achieve either fault tolerance or data locality with their customers. So if you've got customers in Australia and you've got customers in, say, US or in Europe, you don't want to use a data center in Australia to service the US people, et cetera. That's slow. However, we can use the concept of data centers to separate our Spark jobs running on top of Cassandra versus our normal queries that we want to achieve in, say, single-digit milliseconds. The way this works inside Cassandra is basically just common sense. So if you had a large data set, say in a traditional single-server database, and you took a backup, where would you put the backup? Would you put it on the same server? Probably not. Would you put it on a server with the same network switch, or power supply, or internet connectivity, anything like that? Well, you probably wouldn't. So that's not how Cassandra does it. If you ask for 3 replicas and you have, say, 3 or more racks in your data center, then it will put a copy of the data on each rack. This means that we can handle full rack outages and network partitions between racks without having any downtime. That isn't that interesting from a Spark point of view, though. The more interesting thing is you get to group your racks into data centers. Now, they don't have to be real data centers. You can make it up. You can lie to Cassandra. You can say, hey, nodes over here, you're in data center Chris. Servers over here, you're in data center, blah. And this means that we can isolate our Spark jobs to run on nodes which aren't customer-facing. To see that in action and how, say, a single write or read works in Cassandra, imagine we did have a 2 data center setup. These could be physical data centers. They don't have to be. Imagine rather than DC1 and DC2, we had DC Cassandra and, say, operational and DC analytics. When we do a write inside Cassandra, we specify a consistency level. That dictates how many of the replicas we actually want to get to before we consider the query complete. And in this example, we have 3 replicas of the data in each data center. So if we say we want a consistency level of 1, then we go to 1 node, and then we're kind of done from an application point of view. But in the background, it is asynchronously replicated within the same data center, then sent over once to each other data center, and then replicated within them. So a really common scenario is to have our operational application doing things on here, on inside this data center, asynchronously replicating to these other nodes. We then run a Spark job on this side, which writes into the analytical data center, and it gets asynchronously replicated back, which means that we can read it from an application point of view. So let's have a look at some examples for that. So the example we're going to look at is storing weather data. But this data model is virtually the same as one I'm doing, which is actually user interactions with my system. I've logged on, I've logged off, I've watched some Batman, I've bought a movie, etc. And the only really things we need to understand from a Cassandra point of view is how the primary key works. So when I was talking about the hashing and the partitioning to decide which node the data belongs on, that's the bit in the first parenthesis, so the weather station ID. So if we were to actually query this with a pure Cassandra application, we could only do queries that contain the weather station ID. We couldn't do something which said, what's the weather station with the highest rainfall, or the highest temperature, etc. This example only includes temperature. The rest of the primary key, so the year, the month, and the day, and the hour, dictates the order the data is stored on disk on a single node. So just to recap that, the first part of a primary key inside Cassandra dictates which node it goes onto. That's called the partition key. The rest of the primary key decides the order at which it's stored on disk on an individual node. So that's quite, it means that when we have a very large Cassandra cluster, we have many, many nodes. As long as we're including the partition key, we're going to get similar performance whether we have a 3-node Cassandra cluster or, say, a 100-node Cassandra cluster. But we have to include the weather station ID. We have to include that partition key. And that really does limit you when you want to start doing some more ad hoc querying. Once we've done that, though, then we can use the clustering columns to slice down the data. So to return a subset of all of the data for a particular weather station. And Cassandra doesn't let you do any querying which wouldn't result in you reading the data sequentially. So you have to read it in the order of your clustering columns. So if I'm saving some time series data, so some weather station, what I can do with this is retrieve the last 10 weather events. I could retrieve the weather events for a particular weather station between time X and time Y. But then that's it. That's pretty much all I can do with pure Cassandra. But you eventually, and I believe that everyone who actually runs a Cassandra cluster will eventually run Spark. This is what I've generally come to. Because at some point, we want to start doing some ad hoc queries. And that's where Spark comes in. A few examples you could think of is we partition by weather station ID. Now we want to do reporting based on all of the stations. Or perhaps I've stored all the weather station or raw weather data, but I want to start doing group by and aggregates, etc. You can't do those directly inside Cassandra until Cassandra 3, but then you have to do it within a partition. So that's still not overly useful. And what we're going to do, as I've tried to allude to, is set up our Cassandra clusters so we can run Spark just on some segregated nodes. And then when we get down to the actual node level, so if we say in this data center, in this guy, what we're actually going to do is co-locate Spark workers with our Cassandra nodes, right? So the Spark Cassandra connector is then responsible for making sure that when we take a Cassandra RDD and when we partition that RDD, we're only going to make Spark partitions made up of Cassandra partitions that live on the same node. So if I ever say the word partition without saying Spark or Cassandra before it, you may throw a tomato at me, because all I'll do is confuse you, because we both use the same terminology. The other thing that the connector does is it hints to Spark where to execute particular tasks. It says you should really execute it on that node because it's co-located with the Cassandra node. And this is a nice little picture I stole off Russell, a good guy at DataStax. So if we remember how the Cassandra replicates data, so each node owns a range of that hash function. This looks a little bit different if we do something with vnodes. That is where each Cassandra node pretends to be lots of other nodes. And the Spark Cassandra connector, what it does is it builds up a Cassandra RDD, which is partitioned from token ranges that only exist, so ranges of that hash function that only exist on the same node. So when we execute an individual task, we should be able to execute it on the same node as the Cassandra node. And quite frankly, the way in which Spark interacts with Cassandra, it is very easy to completely destroy your Cassandra cluster. No application other than a Spark application can hit Cassandra quite as hard. So that is why we need the workload isolation. You will easily have some very unhappy customers if you decide to randomly run, full table Spark jobs on your production cluster. And so just to reiterate that home, I want you to take this away, is another way of looking at it is to say each Spark partition is really made up of token ranges that live on a single Cassandra node, which results in that each Spark partition is only made up of Cassandra partitions that live on the same node. So let's go back to an example of this, and what can we do? So we'll go back to the raw weather data. What we typically do inside Cassandra is we would store raw data, and we'll store lots of it. But what we'll also do is change our ingestion application to write that data in multiple ways. Because we can't do the type of ad hoc querying we're, say, used to from a traditional database. And the way which I've typically done that is to write Java code or Scala code or whatever language I'm using. But at some point, we're going to do slightly more complex stream processing so we can start to use something like Spark Streaming. So if we remind ourselves what queries we could do against this directly. So we've got the weather station ID as the partition key, and then it's ordered by the time. So the only thing we can do from Cassandra point of view is to do these time slices. Now, the first use case of using Spark on top of this is to do complex querying within a Cassandra partition. Now, because we don't have the expressiveness of SQL inside Cassandra directly, we might have tens or maybe hundreds of megabytes inside a single Cassandra partition. So we can start to run mini, I'll call them, Spark batch jobs on a single partition, and we can even consider that to be an operational query. That's going to come back in probably the tens to hundreds of milliseconds. So a really silly example is one here. We actually include the weather station ID. All right? So the partition key is inside our Spark query. So when we take data from Cassandra into Spark, we can get Cassandra to filter it before we get there. So the only column we're taking is the temperature in this example. Now, Cassandra doesn't store data in a columnar fashion. So we're not really efficiently using disk the best here, but it's still a good way of not bringing too much data into Cassandra. Now, of course, in this example, it's actually been collected. I'm just putting it into a stats counter. But vastly more likely would be I'd be saving this into a Cassandra table, which could be read by a different application or a different part of my application. Or because this is in an individual partition inside Cassandra, I could probably execute this on demand. So someone comes in, and then they do it. But as of Cassandra 2.2 and 2.3, we've got things called user-defined functions and aggregates. You could do this kind of functionality purely inside Cassandra. Then we can drop the partition key and start to do full table analytics. So again, this is a bit of a silly example. It's not actually what the application does. I just wanted to print something out. Is we drop the where clause, and suddenly this Spark job is going to be executing across an entire Cassandra table spread across potentially tens, hundreds, thousands of nodes. But it's going to be separated up into small tasks and then obviously executed. And this is something we can never do with Cassandra. I'm never expecting Cassandra to support anything which really spans an entire table. It's not an operational query. It's not what Cassandra has been designed for. But at some point, either of those are not going to be quick enough. And we're going to want to start to do things on the fly as we're ingesting data. And I think there are two ways of doing this, and it depends what your background is, which you prefer. So the way I've done this in the past is I've got my regular operational application. It's facing the customers. What I will typically do is want to store that data inside a durable database as quickly as possible. I do not want to lose it. The other thing I want to do, so imagine the raw weather data table. The other thing I want to do is build up other tables which can have almost like materialized views. But I do not want building up of those views to affect me saving the data. I don't want to lose data. So we can actually use Spark Streaming to both save the raw data to Cassandra and then build up some aggregates and save some other tables. Or, which is what I've commonly done in the past, is have an ingestion pipeline which saves to Cassandra, but then also puts the data on a queue, which can then be picked up by Spark Streaming, which then actually then does some aggregates and things and saves things to the same Cassandra database. I like that separation, but if you're building a single platform and you're happy to make your Spark Streaming job highly available and know that if that goes down, your ingestion of your customer data goes down, that's fine too. An example of one in this would be keeping track of the aggregate precipitation from an individual weather station. As I said, from our original table, we can't really do that. We can't do a query like that. But what we could do is keep a table up to date. So the primary key for this is very similar to the last one. So it's got the weather station ID as the partition key, and then it's got the year and the month and the day. So we've dropped off the hour. And we've used a really cool type in Cassandra, from Cassandra 2.1, called a counter. Now that's, rather than setting a counter to say 50 or 60, etc., what you're doing is you're just incrementing and decrementing it. So previously what I've done is I've actually written code, so forget about Spark Streaming for a second, to keep counters, lots of counters up to date. So as I ingest data from my customers, etc., or from what my customers are doing, I'm then writing to tables which have counters, which are keeping these almost like materialized views. So when I want to see the daily aggregate precipitation, it's there. I don't need to do a query to work it out. And I can, and I often have many of these tables. So one raw weather data table and many, many materialized view tables. I hesitate to use the term materialized views now because Cassandra, as of 3, has a feature called materialized views. So how would we do that? The advantages of keeping these tables up to date is obviously, if we're dealing with data set sizes greater that we can build up ad hoc queries to do this, then we can have cool little views like this. So we can keep track of all the weather station IDs, daily aggregate precipitation. So just to show you an example of this, and this is from a killer weather reference application that was mainly developed by Helena, who's talking later today. I'm referencing her talk soon, so you can go and hear more about that. But essentially, it takes data in the form of CSV, and it takes more things than the temperature. I just removed them all from my examples just to focus in on a couple of to one field. But in reality, it contains lots of things. It's got the pressure and wind direction, wind speed. So of course, we can take this off a queue like Kafka, or a topic like of a Kafka topic. We can parse it. We can then save it directly to Cassandra using the Spark Cassandra connector. And then what we can also do is obviously start to use that same stream to fill up other tables inside Cassandra. So none of this is Cassandra specific. All it's doing is creating a streaming context, taking the data from Kafka, splitting it, shoving it into a case class. But once we've got that, we can use the Cassandra connector to save the raw data. So this looks like magic because it's only a small line of code, but because our case class matches our Cassandra table, the only thing we need to do is do save to Cassandra. That's going to give us all of the raw data. That's actually the part which sometimes I would have separate. I would have a separate ingestion application that puts it into my operational database and then sends it to my streaming jobs. But that's up to you. Once we've done that, then we can start to play with that stream. So if we remember our daily aggregate precipitation table, is we can map that data into something which looks like the new table. And this is where the magic of the counter comes in. Because all we're really doing is taking out the values we need and then calling save to Cassandra on that stream again. And what that's going to do is the actual addition is being done inside Cassandra, inside the counter. If we use, say, an integer field here rather than a counter, we'd need to be stateful. We'd need to have the current precipitation, we need to add it on, and then we'd need to replace it in Cassandra. The advantage of the counter is we're just updating a counter and keeping it up to date. If you want to hear more about this kind of stuff, I'm going to plug another talk. You should go to this one this afternoon, because I think this will be a really great talk. So to conclude, Cassandra is an operational database. There are people trying to use it for other things, and that is absolutely fine, and you should go for it. But from my history with Cassandra is very much, it's an operational database that deals with data set sizes that can't be used in traditional databases. A huge problem with that is I end up with so much data in there, I can only do the things I designed it to do. I can't then change it. I couldn't say query it a different way. Regularly, I use Spark to take one Cassandra table, which might be extremely large, take it out, do a single map, and then save it to a new table. And within about 2 lines of Spark, you can parallelize the moving of one set of data to another table, partitioned a different way with different clustering columns. That is a huge use of Cassandra that's been used by a lot of people. We can start to use Spark to do in Cassandra partition, like more complex querying, but I think that will be phased out because we're getting that functionality directly inside Cassandra in later versions. But what it really, I think it comes into its own is when we don't want to take our data out of Cassandra and put it into something like HDFS and then run something like MapReduce or Spark on top of that. Because that can take a lot of time. And don't get me wrong, if you run the equivalent jobs on a Spark on top of Cassandra versus Spark on top of HDFS, the Cassandra one will be much slower. There are people working on making it faster, and I'm sure it'll improve. But it's not what Cassandra's optimized for. It's optimized for sequential access within a partition and reading entire rows, not sequential access across huge data sets and just reading out a particular column. More and more, though, I think that we're going to be using Spark with Cassandra to build up, to do things which people have been doing Cassandra for years, which is pre-build aggregate tables, pre-build views on some raw data. And that's where I think Spark Streaming will start to be used more. I generally keep it within my application for most of the time until it gets complex. But as soon as I'm spending more time trying to work out how to aggregate data inside some code, I'm going to jump over to Spark Streaming. And that's all I've got. So thanks for listening. We have 3 minutes and 46 seconds for some questions, if you've got any. And I'll be around for the rest of the conference.
Hi. So you mentioned the fact that you need to install different racks, and probably it's better to divide what is production and where you store the data for using Spark on top.
Yeah.
So my question is, because many companies, they use these distributions like, I don't know, Cloudera or Mapr or Hortonworks, and they generally come with Hadoop and the H-based version already installed. So and Spark, so everything is in the same cluster.
Yep.
So it makes sense if you already got your data in Cassandra and then you want to do your analytics on top of, you don't want to replicate the data. But let's suppose that we're doing an ingestion just specifically from a stream, we just store for the purpose of doing analytics. Then would make more sense to store in HBase, and then you don't need to maintain 2 different clusters, one for Hadoop and Spark, one for Cassandra. Moreover, in HBase is you can, columnar, and also you can do like co-processing for aggregating. You can push down filters, so it gives you a lot of. It's a very rich API. Have you considered that?
So it's a really common question. I think it's where you start from. If you start from building an analytical stack, I think most people would go with the stack that you were talking about. But if you start from an operational system, which you've already used Cassandra for, then I think that's where this stuff comes into play. If you're using something like DataStax Enterprise, which is a distribution of Cassandra, which includes Spark workers embedded in the same thing and the ability to run Hadoop as well, I still see that as I've got my operational database, I want to do some stuff on top, not I'm building a from-scratch analytical system with Cassandra, though people are starting to do it. I'm not.
Thank you.
Any more questions? No.
Hi, Praveen here. So my question relates to the PySpark Cassandra connector. The Spark Cassandra connector is released by DataStax, and it's also being maintained, if I'm not correct.
Yep.
Do you plan to work as a company to support the PySpark connector for Cassandra?
I don't work for DataStax. I'm an independent consultant, etc. But you'd have to ask a DataStax person.
Any other questions?
All right, so when you showed that slide where you were separating the workload separation between what is the operational cluster and the analytical,
yeah.
does that also separate where does the Spark cluster reside? Because when we want to do the query that actually loads that data into the analytical layer, that would ideally be done with local locality as well. So what
Correct.
is the notion here of analytical if we do need to have Spark on both sides?
So it's a single Cassandra cluster split into 2 data centers, which don't have to be separate physical data centers. We co-locate the Spark workers on the same nodes, just on the analytical nodes. Yep, you want to do like analytical jobs which then write, and you want the data locality there as well. It's then up to Cassandra to asynchronously replicate the stuff you've written from your analytical jobs back over to the operational side, and it'll do that for you. That answer your question?
Okay, so the last one comes right there regarding the resources that you have on those nodes which have both Spark and Cassandra. Both of those are really resource intense. How do you manage to divide those between those two?
C groups. So you can, I would pin CPUs to Spark and to Cassandra. I wouldn't just let them fight at it, because they will fight at it.
Okay, and I think Chris is going to stick around afterwards if you have more questions. Please join me in thanking our speaker.
Thank you.